Assalamu alaikum everyone. I hope you can hear me properly this time. So this is our second lecture for the course CSC 4615 Wireless Networks, alternatively CSC 4671 Wireless and Mobile Communication. So in this lecture we are going to learn about the Internet and access networks and what role access networks play in the Internet from a broader perspective. Well, we know what Internet is, but really what is it? Can we define it precisely? We have learned many definitions throughout the previous semesters or previous courses, but actually we can define it in many ways. The first is we can define it using the basic components or what the Internet is actually made up of. In that sense, the Internet is actually millions and millions of devices connected or interconnected through wires or through wireless media. We can also define it based on how it works or how it functions. And in this regard, we can say that the Internet is an infrastructure that provides services to all other applications which use the Internet. So now we are going to define the Internet from various different perspectives. Now, as we have already defined before, the computer network is a connection of millions of devices, or actually we could say it's computers, right? Because the term computer network comes. Well, a few years ago, this might be the case because the Internet was usually built up of traditional desktop PCs, Linux workstations, and usually primarily it was used to store or transmit emails and web pages. But that was a few years ago. Internet in the current age is much more different, and it's not so traditional anymore. Now it contains a range of devices starting from laptops, smartphones and tablets and other computing devices to even devices which we use for entertainment like TVs and gaming consoles. So now can it really be called a computer network? Because the computers are not the only things interconnected anymore. In the non-traditional network, the devices are called hosts or end systems instead of being called just computers. So as of July 2011, nearly 850 million end systems were connected to the Internet, including smartphones, laptops and other devices which connect to the Internet not as regularly as the other devices. An estimated 2 billion users were connected to the Internet. Now, that means in 2020, experts estimate a total of 31 billion IoT devices which are being installed or will be installed by the end of 2020. So IoT devices are actually devices which can be of any sort of category. For example, it can also be an air conditioner, or it can be TV or anything. Those who have already worked with or studied about Internet of Things, they probably know what I am talking about. Now, besides the hosts or end systems, the Internet also consists of communication links and packet switches. These links connect the hosts or end systems with the packet switches, and they also connect different packet switches with each other. And packet switches are actually just devices which forward packets, which you might have learned in the previous semesters. Packets are simply smaller collection of data which can be sent from one device to another through these links. And the links can be of various forms. It can be a wired link, or it can also be a wireless link, in which case the data travels through space or the atmosphere in the form of electromagnetic waves. Now, different links can transmit with different transmission rates, and these transmission rates are measured in terms of bits per second. For example, if data rate is considered as 1 gigabyte per second, this means, although it's very difficult to find such a rate in our country, but 1 gigabyte per second means in each second 1 gigabyte worth of data can be sent from the source to the destination. A series or sequence of these links from a source host to a destination host is called a route or a path. And each end system accesses the internet through these transmission rates and through these routes or paths, but mainly they access the internet through another body which is called the Internet Service Provider or ISPs. These ISPs are the mediums through which host systems or end systems connect with the internet. Now, internet service providers can be of various types. For example, the ones that we usually use are residential internet service providers. These providers use various medium. The first one is local cable, and through local cable we can actually access the internet using broadband connection. Although nowadays we don't see this much, but previously we had modems which connected the broadband line through the modem to our end system or our PCs. So before the internet came, the local cable was used to provide every house with television networks, and using the same network now internet is also provided, and this network is now called the local cable network. The second is the digital subscriber line, which is actually provided by telephone companies. And just like the television companies, the telephone companies also have a network throughout the country or throughout the world even. Using this network, we used to communicate with each other through our landlines. Now using the same network, they provide us with internet, and the data lines which were used to communicate on using voice is now used to communicate in terms of data. The telephone companies throughout the world are renowned. For example, AT&T and various other companies are there. And in case of our country, there is another renowned company called BTCL. Besides residential ISPs, there are also corporate ISPs which provide internet connection to different organizations or corporations. And there are also university ISPs which provide internet connection to universities. For example, in our case, IIT also has an ISP which provides us with internet connection. Now, there are also other kinds of ISPs which provide Wi-Fi access in different public places, for example, airports, hotels, and coffee shops. In the right, we can actually see a figure which shows us the examples of different sorts of networks. For example, home network, enterprise network, mobile network, and all of these networks are actually connected to the internet through the local or national ISPs. In a few seconds, we also learn the different kinds of access networks, because the three that you can see here, mobile network, home network, and enterprise network, these are actually three different types of access network. Now that we have learned what the components of internet are or how the internet is built up, we are going to learn a different view of the internet, which is called a service view of internet. According to this view, the internet is actually an infrastructure that provides services to applications. Now, what does that mean? This means that there are many applications distributed throughout the world, which is why they are called distributed applications, because they are distributed but they are still connected with each other, and this connection comes in the form of the internet. So it can be stated in a way that the applications actually take help of the internet to communicate with each other, or maybe the same application are distributed in different places, and those instances of the same application communicate with each other using internet. So in this sense, it can be said that the internet is actually a service provider which provides service to various applications. So these applications can be of different types, for example, electronic mail or email or web serving, which is actually related to the browsers that we use, for example, Chrome or maybe Mozilla Firefox. Then there are also social networking applications like Facebook and Twitter. There are voice over IP or internet protocol, which applications actually provide us the means to communicate abroad or in the same country. The examples of this type of application are Skype, WhatsApp, there's also Viber. And also there are many applications like games which require internet connection and which can be played in a co-op manner, and also video streaming applications which also use the services of the internet. So to make this a little bit clear, let's see an example. So suppose you have an exciting new idea for a distributed internet application, one that may greatly benefit humanity. Okay, maybe that's too much, but let's say it's going to benefit humanity, or one that may simply make you rich and famous. How much you go about transforming this idea into an actual internet application, because that actually requires a lot of work and a lot of thinking. So because applications run on end systems or hosts, which we can consider as our PCs or laptops, you are going to need to write the programs that run on the end systems, and you might write it in different languages, for example in Java, C, or Python. Now because you are developing a distributed internet application, that means one that will be using the internet to communicate with various other applications or instances of the same application, the programs running on the different end systems will need to send data to each other, right? And they're supposed to send this using the internet. And now we get to a central problem, one that leads to the alternate way of describing the internet as a platform for applications, because all the applications will be using this internet as a media or as a platform. Now how does one program running on one end system instruct the internet to deliver data to another program running on a completely different end system? So let's say you're sitting in Dhaka and you are sending the data to an application which is in USA, right? So they're separated by huge distance, but that distance becomes very small due to the internet. But how are you going to take help from the internet, or how are you going to tell the internet to send this data from here to USA? So the answer is using Internet Application Programming Interface, or API. So what is API? Okay, a few examples you might already know. For example, HTTP. So whenever we write the address of a website, if you remember, we write HTTP or HTTPS. And another example is REST. So those who have worked with developing applications like Android applications might have also worked with REST. So these two are well-known APIs. So what are APIs actually? They are a higher level form or versions of protocols. Protocols define how a data is sent from one source to a destination in the lower levels. So protocols define when the data will be sent, how much data will be sent, right? So that is actually a lower level communication. APIs are much more higher level because they are communication rules set between two applications. So they also contain protocols, but they also contain higher rule set which are followed by applications. So in short, we can say that APIs are the rule set which define how one application will communicate with another application by using internet or through internet. Now let's see an example of a protocol, or let's just simplify it, because you already know or you have already learned a lot of protocols, right? But in a simplified version, what protocols are. So humans have rules which define how to communicate. For example, in the figure on the right, you can see that the female here is saying hi to the male and the male is saying hi back. So this is actually a sort of custom, right? Although many people don't follow it. And then the female asks the question that she needs to ask, and the male answers. So the question is, have you got the time? And the answer is yes, it's 2. So in a similar fashion, machines also communicate with one another. So in this example, the hi is a TCP connection request and a hi back is a TCP connection reply. So if you remember, whenever you have learned protocols, then you might remember that whenever a node wants to send a data, it asks for permission to another node, and that node replies with an acknowledgement, and then they communicate. So here the acknowledgement and the question asking is done through TCP connection, and then the website is asked, or the website is actually given, and based on that website, the server on the right returns the file that the end system is asking for. So these rule sets that the network devices follow are called protocols. Now that we've learned what protocols are and what role they play in communication between one device to another, let's see how the internet is actually divided into separate parts. So at the very beginning, what we are going to see is the network edge. So if you can remember, we are saying that PCs are end systems, but they are named such because they are actually at the very end of the network, or we can also say they are at the very edge of the network. So the network edge usually means the hosts or end systems. Likewise, the name hosts is also given because these PCs or laptops host different applications. So if you recall, the end systems are a combination of different types of computers. It might be desktop PCs running Windows, or it might be Mac, and it might also be Linux. And it might also be servers. It might not just be computers, but servers are also end systems, or they're at the edge of the network. And servers usually contain websites, and they host emails, etc. And it might also be mobile computers, which are much more prevalent now, like laptops and smartphones. So these hosts are basically of two types, clients and servers. So as you can clearly understand, the clients are those devices which we use, general use devices. And servers are those devices which store information in huge quantity. And when we actually sit in a PC or we look at Facebook, we're actually looking at a file which is stored in a server somewhere else. So in the figure at the left, we can see an example of an end system interaction. So as you can see, the laptop at the very top in a mobile network is conversing, or let's say talking with a server at the very bottom in an enterprise network. So both of these are actually end systems, and they're connecting to a variety of devices. At first it's connecting to a router, then to a national or global ISP, then to a local or regional ISP, and finally it reaches the router of the enterprise network, where through the router it connects to the server from where it needs the information. So clients are usually desktops and mobile PCs, smartphones and so on, whereas servers tend to be much more powerful with a huge amount of processing power and memory. So servers store and distribute web pages, as we have already said, stream videos, and they also relay emails. So I've already given this example of Facebook. Let me give another example. Even when you're using YouTube, the video that you're watching is actually stored in a server in a remote place, and that server belongs to the network of an enterprise, and you are just sitting somewhere, maybe connecting through your mobile in a mobile network, or maybe you are at your home connecting to a broadband connection, which is what? A home network. So both of the devices that we are seeing here, that means the server and the PC, both of these devices are end systems, but they are of two different types, clients and servers. So now that we know what the edge of the network really means, we are ready to understand what access networks mean. So if we define access network, then we can say that it is the network that physically connects an end system to the first router, also known as the edge router, on a path from the end system to any other distant end system. Okay, I know this sounds fancy, but it's actually quite simple. Access networks basically connect you, which is the end system, to another end system, right? But it's somewhere in the middle. For example, in the figure at the right, if you can see, there are many networks here: the home network, enterprise network, and mobile network. So you are anywhere in a mobile network. You can be in your car using a mobile phone, or you can be the laptop, and you are connecting to the internet through what? Let's say in case of mobile network, you're connecting to a BTS tower, right? And that tower connects to a router, which eventually connects to the national or global ISP. So the network which connects you to the national or global ISP is called the access network. So if you can see here in the figure, all the lines which are marked in blue, these are the access networks. Okay, so in case of home network, even starting from the router to the local or regional ISP router, the entire path is called the access network, because you are just sitting on the laptop. Okay, the router is not the end system. The router provides you with internet access also. So you are just sitting on the laptop, and the entire path connecting from the router or the wireless router that you are using to the local or regional ISP holders router is called access network. So now if you look at the definition again, we'll understand the network that physically connects an end system. So you are the end system. So it connects the end system to the first router. The first router of which network? The first router on a path from the end system to any other distant end system. Okay, so you are connecting from one end system to another distant end system, and the very first router or network which connects you to the ISP, and eventually from the ISP to the other access network, and then through that access network you connect to the other end system. So as we have already seen, there are different types of access networks used for different scenarios. For example, there are residential or home access networks, then there are enterprise access networks, and there are also wide area access networks. So the most prevalent home access networks are DSL or digital subscriber line, which is actually provided by the telephone companies or telcos, and cable, which I've already talked about. These are provided by the television cable owners. So these two are primarily the types of home access networks. Then there's also enterprise access networks, and the most used technology in enterprise access networks is called local area network or LAN, which you actually used if you stayed in the IT halls. And this local area network can be Ethernet, which is wired, or also Wi-Fi, which is wireless. And although this book is a bit old, nowadays Ethernet and Wi-Fi, both of these are also used in our residential areas or home places. So they also can be considered as home access networks. Now, wide area access networks are usually spread throughout an entire region. For example, the mobile networks that we are using, or the mobile phones that we are using, these are wide area networks. And although the example given in the book is 3G and LTE, which can also be called 2G, 4G is already being used, and 5G is also in the market. So all of these are examples of wide area access networks. Now this is an example of a residential access network. So here, as you can see, the same line or wired connection is being used for both internet connection and your home phone's connection or landline. So the same line is actually splitted and passed through a DSL modem, which actually converts the data, digital to analog conversion, if you remember, and the other line goes directly to your home phone. Because this line usually carries voice information, so the existing phone line information is also given here, which is 0 to 4 kilohertz, which actually defines data transmission rate. And it also says that it has a 4 to 50 kilohertz upstream data and 50 to 50 kilohertz to 1 megahertz downstream data. So upstream data means the speed at which data can be sent, and downstream data means the speed at which data can be collected. And this line is connected to the central office, which eventually connects to the internet for your home PC and also connects to the telephone network for your landline. This is another example of home network, but in this case it is actually a hybrid network which uses fiber coaxial access network. So if you remember, you have already learned these things, right? Fiber optic cables and coaxial cables. So I'm not going to go into details. I'm just going to say that using this cable network, you can actually connect to hundreds and millions of homes in the same using the same cable. And this fiber node, from which the cables start, is connected to the central cable head end, which is eventually connected to the internet. Now this is an example of Ethernet, or you can also say this is an example of an enterprise access network. So here you can see all the PCs are connected to the Ethernet switch, which is eventually connected to the institutional router, and the institutional router is connected to the institution's ISPs. The Ethernet switch is also connected to the server. So in our case, you can say that the server that we have in our academic building is the server that's shown here, which is connected to the Ethernet switch, and that Ethernet switch is connected to all the PCs in our academic building or even in our halls. And as you can see, the speed that we get, or the data rates that we get here, are usually faster than the residential networks. This is another example of a home network, but instead of hybrid connection, this is just a cable connection. By cable, I mean this is actually an Ethernet connection. So we have seen what edge of the network is and what access networks is. So the last topic for today is the network core. So the part that is the network edge is at the very end of the network, and the rest of the part, which is at the middle of the internet, is called the network core. So the network core is usually a mesh of packet switches and links. There are usually no PCs or no servers in the network core, and the network core is completely built up of devices which work with data packets and forward data packets. So the message from a host is broken down into packets or smaller size data holders. You already know what packets are, I guess. And these packets travel through each link or switch and eventually reach the destination. So packet switches are mostly two types. One works in the network layer and one works in the data link layer. Okay. So the network layer switches are called routers, and the data link layer switches are called switches, simply switches or link layer switches. So routers are much more intelligent compared to switches, and switches just forward packets in a direction, while routers can compare that packet with its table and take intelligent decisions. So most of these topics are already discussed in the previous courses, but I'm just going to show you the example of how you can divide the network into network core or the network edge. At the left, if you can see this figure, it's the same figure that we saw before, where we divided the network into access network and also the network edge. So now you can see all the routers which are in the let's say ISP region, or which are the routers in the enterprise network or the main router of a mobile network. All these routers are actually part of the network core. They might also be part of the access network, but the devices of the network core will never be the part of the edge of the network. So the network can basically be divided into two parts, the network core and the network edge, and the access network is somewhere in between the network core and the network edge. So with this, I'm going to end the lecture for today. So if you have any questions, feel free to ask in YouTube. And at the very end of this slide, there are two references which refer to the data that we have shown in the previous slides. Okay, so I'm going to end it here. Assalamu alaikum wa rahmatullah.